Okay, we're going to perform an analysis of the rational function in example 8a from notes 4.1 days 2 and 3. So to begin analyzing the rational function, we're going to go ahead and factor, which is always the first step when we're analyzing a rational function. So we're going to factor the numerator as x minus 4 times x plus 1 over the denominator, which is x plus 2. And now we're going to go through the steps of our analysis. Let's begin by finding the y-intercept. To find the y-intercept, we're going to let x equals 0. So we're going to evaluate f of 0, which for this function will have negative 4 over 2, which is negative 2. So our y-intercept is going to be the point 0, negative 2. Okay, next we'll see about x-intercepts. Okay, x-intercepts are going to be points where the numerator equals 0, but the denominator is not equal to 0. And we don't want the denominator to be 0 because then the function would be undefined. Looking at our function, the factor x minus 4 gives us an x-intercept at 4, 0 with odd multiplicity because that factor occurs once in our function, and another x-intercept at negative 1, 0 also with odd multiplicity. Okay, we're going to move on now. We're going to go ahead and find vertical asymptotes. Okay, when we look for vertical asymptotes, we're going to look at the denominator. And we want to find values that make the denominator 0, but the numerator not equal to 0. And more explicitly, if we cannot cancel the factor out of the denominator, then we will have a vertical asymptote. So this factor, x plus 2, does not have a common factor in the numerator, which means we will have a vertical asymptote with the equation x equals negative 2, and in this case with odd multiplicity because that factor only occurs once in the denominator. Next, we're going to see if we have any holes for this function. Okay, holes occur when we have a common factor in the numerator and the denominator of greater or equal multiplicity in the numerator than the denominator. So we're looking for common factors in the numerator and the denominator. In this case, there are none, so we have no holes for this rational function. The last thing we're going to look at is the end behavior, or what kind of infinite asymptote we have. Okay, so if we have an infinite asymptote, the two that we've studied are horizontal and slant asymptotes. Oops, let me fix that. Asymptotes. Okay, so we're going to look at the degree of the numerator and the degree of the denominator. In this case, the degree of the numerator is equal to 2, because we have a quadratic function here, and the degree of the denominator is equal to 1. Since the degree of the numerator is greater than the degree of the denominator, we have no horizontal asymptote. But since the degree of the numerator is exactly 1 more than the degree of the denominator, we will have a slant asymptote for this function. In order to find it, we're going to use synthetic division. So I'm going to set up my synthetic division. I'm going to put my coefficients of the numerator across the top line. And on the outside of the L, I'm going to put the value that makes the denominator 0. I can use synthetic division because I'm dividing by x plus 2. If I didn't have a nice factor of the form x minus k, I'd have to use long division. But here I do have the nice form, so I'm going to go ahead, do my synthetic division. And now I need to interpret it. The remainder term is not relevant for my slant asymptote, so my slant asymptote is the equation y equals x minus 5. Remember, the remainder is not relevant to the slant asymptote because as x goes to plus or minus infinity, this remainder term that would be 6 over x plus 2 goes to 0. The last thing we need to determine is if the graph crosses the slant asymptote. Okay, to do that, we are going to set the original function equal to the slant asymptote. So does f of x cross slant asymptote? Okay, that's what we want to know. So let's go ahead. Let's set x squared minus 3x minus 4 over x plus 2 equal to x minus 5. We're going to multiply both sides of the equation by x minus 2. So x plus 2, I'm sorry, times x minus 5, which is going to give us x squared minus 3x minus 4 is equal to x squared minus 3x minus 10. And we're going to cancel out the x squared and minus 3x from both sides. Those would subtract off, and we'd be left with negative 4 is equal to negative 10, which has no solution, which means we conclude that the graph does not cross the slant asymptote.